So friends, in this session we are going to discuss with the continuation of the previous circular queue data structure, right? So here we are going to start deleting the elements. See the same diagram of the previous video I have used, right? So now this is the actual data structure which I have got, okay, after the end of performing certain operations. So now we are going to start deleting the elements, right? So now from where we will be deleting the element? So I am going to delete the elements from the front pointer. So while deleting, so this is my front pointer. So after deleting, A will be deleted. So front will be pointing here. So now B will be deleted. Now front pointer is pointing to this location. So now I am going to delete this C value also. So now front is pointing here and D is also deleted, E is also deleted and F is also deleted, right? So now F is also deleted. So is there any other element that is being present for deleting? So after deleting all the elements, I must have to print as Q is empty, because if an attempt is made to delete the elements that is not present here, it is a waste of time, isn't it? So I must have to print that the circular queue is empty. So now what is the condition for the circular queue is empty? After all the elements are deleted, there is no use of implementing the front and rear pointers, right? So now what will be the values of front and rear pointer? So it is front is equal to rear is equal to -1. So for example, when I am going to implement any operation or any algorithm, so each and every time when I am deleting the element from the circular queue data structure, I must have to check whether front is equal to rear is equal to -1. So each and every time I must have to check this. So this is the condition for checking whether the queue is empty or not. So please make a note of it. Front is equal to rear equal to -1 means that the circular queue is empty. Okay friends. So now we are going to do some alternative way, right? Let's try that. So friends, after performing certain number of operations, insertion, deletion and so on, finally I am getting a data structure as W, X, Y and Z. Okay, so now I want to insert certain element inside the circular queue data structure. So how can I do? In circular queue, we have the possibility of making the rear pointer to point back to the first index value, isn't it? So how can I do? So manually I can make it, but if I am going to implement an algorithm, how I can do? So I must have to check the condition for front and rear pointer, right? So now what is the value of the front pointer? So the front pointer value is 2. Okay, so what meaning is the 0th index value and 1 index value are empty, isn't it? So that's why front pointer value is 2, right? So now next what I should do, I must have to check the value of the rear pointer. So rear pointer value is 5, right? So what is the meaning? The circular queue data structure has reached the last index value. Okay, so I cannot able to insert. So now what I should do is, since these two spaces are free and R is pointing to the last index value, I must have to move this rear pointer to point back to this location. That is, I must have to reinitialize the value of rear pointer to 0. Okay, so what is the condition? If front pointer is not equal to 0 and rear pointer is equal to the last index value. If these two conditions are satisfied, I can reinitialize the rear pointer to this first index value, right? Can you follow? So now I am going to write the condition. So condition is if front is not equal to 0, because it is 2, it is not equal to 0, right? So now and R is equal to 5. Okay, R is equal to 5. So 5 is the last index value. If both these conditions are satisfied, what I should do? I must have to reinitialize the value to 0. Very important step. Okay, I am reinitializing the rear pointer to 0. Once this command is given, so the rear pointer will be moved to r equal to 0. After moving, now can I insert the element? Yes, I can insert the element. So, any other element if I want, I can insert. For example, yes. Okay, then after that, I can insert t. Now, the rear pointer will be pointing here. Right? Can you understand? Okay, now. So, now this element is being deleted. So, I must have to reinitialize the front pointer to this yes, to 0. Okay, so how can I do? So, initially, that is before deleting this element, I must want to explain it to you. So, once again I am adding the element. So, now after deleting this f, I must have to reinitialize this f to 0, isn't it? So, for that I must have to check this condition. So, first let me check the front pointer. Okay, so front is not equal to 0, isn't it? So, front is not equal to 0. So, meaning is there are certain elements that is being present before 0. Now, and what is f? So, f is equal to n because f is pointing to the last element of the cube. So, now both the conditions are satisfied. Okay, so now both the conditions are satisfied and rear is not equal to n. So, this also I must have to check simultaneously, that is side by side along with this condition. So, rear is not equal to n. It is placed in between the Q data structure, that is circular Q data structure. So, this also I must have to check. So, once these conditions are satisfied, that is the main condition is this and this. If both are satisfied, what I will do is I will delete this element, that is I will delete the element. Okay, I will delete the element present here and I will reinitialize the point to here. Right, then I will be incrementing, reinitializing the front pointer to 0. So, now as usual, each and every time we will be checking all the conditions and we will be performing the deletion operation. Okay friends, so please make a note of this. Right, so this is a very important point friends. So, up to now we have discussed how to insert the element, how to delete the element, how to reinitialize the front pointer, how to reinitialize the rear pointer, one of the important formula if the cube is full, all those things we have discussed. So, now I am going to tell you some of the formulas where you must have to use it in problems. If they ask in problem, how we are going to substitute and find the answer easily. So, that I am going to tell you. Just make a note of it. Right. So, friends, these are the very important formulas, the direct formulas that is being given. Suppose if they ask any question, you can substitute this formula and you can find, and these are all certain conditions. We can also tell it as a formula or as a condition. You can remember this so that if they ask an MCQ, it will be easy for you to understand. So, now the formula for inserting one element, to insert an element inside the circular cube, rear is equal to rear plus 1 modulo size. For deleting a single element from the circular cube, formula is this: front equal to front plus 1 modulo size, and for full, just now we have discussed in the last video. So, the formula to find whether the cube is full or not is this: rear plus 1 modulo size, which is equivalent to front. And so, this is the condition for empty. This also I have discussed. So, if only one element is present in the cube, so that also I told front is equal to rear, right. So, now I will tell you how to substitute this formula. Now, I want to insert the element in the third position. Now, this is my front, isn't it? So, now this is my rear. This is my rear. So, now where is the rear pointer? So, the rear pointer is pointing to the second index. So, they will ask in the question, if the rear value is equal to 2, now where I must have to insert the element. So, at that case, you substitute in this formula. What is rear value? So, rear value is 2 plus 1 more, size may be 4. So, what is 3 divided by 4? So, 3 divided by 4, you will get the answer as 3. So, I must have to tell that in the third index value, I am going to insert the element. that is your year pointer, right? So like this they may ask you, you can directly substitute and give the answer. So for deletion, so where I must have to delete the element if the front pointer is pointing to certain location. So where I must have to move the front pointer, that is in which location my front pointer has to be moved if the element in the 0th value is deleted. Can you understand the question? Where the location of my front pointer will be, okay, if the location in the 0th index is deleted. So that is my question. So what is my front value now? So front value is 0. So 0 plus 1 modulo size value is, so it is 4. So 1 divided by 4 is 1, right? So my front pointer must be pointing to this location after deleting the element in the 0th index value. Friends, I think so it will be easier for you. So why I am writing these formulas and condition is, you must have to remember this. You can give the answer smartly, right friends, rather than going on thinking logically and wasting the time. If you have an idea about this is the way the questions will be asked, you can easily answer, isn't it? So that I have given this formula. So please make a note of it. Very, very important, right? So friends, in the next video, we are going to discuss about its algorithm and its time complexity. Okay, bye and thank you.